Hi everyone and welcome back to this channel. Today we are with a hot and important topic, that is greenhouse gas emission and global warming potential. Probably most of us had heard about it but might not fully understood. So I am going to express it in a simple and summarized way. At the end of this video, we will demonstrate a simple tutorial to estimate greenhouse gas emission and its global warming potential. Hope you will enjoy it. So let's start. So let us try to understand what is greenhouse gas and what is greenhouse gas effect. As shown in the image, that is an animated image developed through AI. Here you can see our Earth is blanketed by atmosphere. Here the sun emits energy in the form of sunlight, which passes through the Earth's atmosphere, and then the Earth's surface absorbs some of the solar energy and the surface gets heated. And then the Earth's surface emits this energy back into the atmosphere as infrared radiation. During that procedure, certain gases in the atmosphere such as carbon dioxide, methane, nitrous oxide, water vapor, etc. absorb this outgoing infrared radiation and trap the heat. These gases don't allow to escape the heat back. These gases are teeny, invisible heat trap and simply called greenhouse gases, what we call greenhouse gases. Trapping the return heat by greenhouse gas is called the greenhouse gas effect. Due to this greenhouse gas effect, Earth's temperature rises and people normally say it's as a global warming or global warming effect. Or sometimes it is called greenhouse effect. So few questions may click in our mind. The first question is whether greenhouse gas and its effect is completely unnecessary or not. The answer is no. We need some greenhouse gas to trap the sun heat, to maintain Earth's temperature suitable to live human being and other living beings. Then the second question, if it is necessary, then why too many noise nowadays about greenhouse gas and its effect? So here is the answer. Here we can see how anthropogenic activities generate sufficient amount of greenhouse gases nowadays. Here anthropogenic emission means emissions due to human-induced activities. Here you can see automobiles, industries, then agricultural activities are generating sufficient or massive amount of greenhouse gases. At the same time, you can see the deforestation is at an alarming rate. So what happens here is, whatever the greenhouse gas is generated anthropogenically, that cannot be balanced naturally. And then we will have a surplus greenhouse gas in our atmosphere. And it is a serious concern. It is a serious concern because it doesn't allow to return the heat back. That means it starts trapping sufficient amount of heat, and due to that activity, Earth's temperature rises. And that's why the global community is deeply concerned about greenhouse gas emission and its warming effect on the Earth. Because this warming effect results climate change and natural disaster. So what we can do? What is the next? We can't control greenhouse gas emission fully due to our modern lifestyle. We can't control driving. We can't stop driving car. We can't stop producing different kind of products which we need in day-to-day life. So what we can do? We can simply mitigate it. And to mitigate something, we must have an idea how to estimate that thing. And to mitigate that greenhouse gas emission, we must have an idea how to estimate, because estimation of greenhouse gas is the first step to mitigate it. So now we must be appreciating it is a high time to mitigate greenhouse gas emission by our own level. How to estimate the greenhouse gas emission from any activity? Estimation of greenhouse gas emission from any activity depends on several factors, several circumstances, several scenarios. It's a complicated thing, but still we can make the thing simpler based on some tool, some guideline, some existing literature. Now I am going to demonstrate a simple tutorial how to estimate greenhouse gas emission from cow manure. I have introduced this tutorial just for the sake of example. So let's see how to estimate greenhouse gas emission from cow manure. Actually, IPCC has developed some guideline to estimate greenhouse gas emission from different waste material. Here we are presenting an example as a cow manure. And here you can see there are several conditions and several scenarios under which we have to estimate greenhouse gas emission. In this example, the storage system is a peat storage and ambient temperature is 25 degrees centigrade. It may change, it depends upon the scenario. And I am not going to discuss about other characteristics like manure characteristic, methane conversion factor, emission factor, etc. We'll cover this thing in next video. So our assumed parameter, that animal type, it's a dairy cow. Manure management system, it is peat storage, that is anaerobic. And we have assumed ambient temperature 25 degrees centigrade. Here you can see that 1 kg of cow manure under this condition can generate can emit 6.2 gram methane and similarly 6.3 milligram nitrous oxide. Now we have to convert this emission in terms of carbon dioxide equivalent. It's a metric measure that is widely used by scientists to convert all greenhouse gases except carbon dioxide in terms of carbon dioxide, and it is based on the global warming potential of each individual greenhouse gases. For example, 1 kg of nitrous oxide emission can potentially contribute 300 times more than that of carbon dioxide, and hence you can say 1 kg of nitrous oxide is equivalent to 300 kg of carbon dioxide. Or in simple word, nitrous oxide has 300 times more global warming potential than carbon dioxide. Similarly, 1 kg of methane has around 25 times more global warming potential than carbon dioxide. So you can interpret the global warming potential of greenhouse gases coming from this manure in kilogram carbon dioxide equivalent. Here you can see I have made some simple calculation here, that 1 kg of cow manure is emitting 6.2 gram of methane, which is equivalent to 0.155 kilogram carbon dioxide equivalent. Similarly, 6.3 milligram of nitrous oxide is equivalent to 0.0189 kg carbon dioxide equivalent. So total global warming potential of openly storage of 1 kg of cow manure equals to 0.1739 kilogram carbon dioxide. So this is a simple demonstration how to estimate greenhouse gas emission from any activity. Here I must say a few important considerations. First, we have considered only methane and nitrous oxide. We have not considered other greenhouse gases because its global warming potential in comparison to methane and nitrous oxide is negligible. Second thing, this emission is based on 100 years of time horizon. Greenhouse gas remains in the atmosphere for different length of time and have varying warming potential. So whatever emission we have made, that is valid for 100 years time horizon. If we consider shorter time horizon, then impact will be more. We will cover all these things in next video. Thank you for watching.